All right, these last couple ones for you guys, these are the more difficult problems that you might be struggling with. So let's go ahead and go through these really quick. Hit pause, go ahead and try the problem. And I'm going to assume that you hit pause, so that's why I'm just starting right now. Here we go. So is this linear? Well, I'm pretty sure that is not linear because you can see the curve. Is this continuous or discrete? Well, it starts here, and that arrow tells me it goes on forever. So it is continuous from here to on forever. So yes, it's continuous. Is it a function? Yes. Even though it kind of looks like it's going straight up, it's not going straight up. It keeps going out gradually. So it keeps going out to the right in the positive x direction. It keeps going up in the positive y direction. So this is a function. And finally, the domain and range. Now, Mr. Nelson does this in class a lot with his students, so maybe we'll try this with you. So if we're looking at Xavier, we're looking at that x-axis. What Mr. Nelson likes to do is he goes, as he's walking, he sees, oh, I see that on the x-axis, this is where Xavier sees his first point. This is at -7. So he'll put a -7 here, and that's filled in, so he'll just do it right there on the line. So I'm going to bring that -7 up, and boom. And then keeps going, and he sees on the x-axis that even though the arrow looks like it's going up, it's also going out. So he also knows that this is going forever this way, and that means it's going on to infinity. And infinity is never included, and so basically he spread this out, but now we can just condense that down and say the domain is from -7 to infinity. If that helps you, definitely do it that way. I would definitely agree with that. I'll do it one more time to show you how Mr. Nelson's going about this again. So here's Yolanda. I don't want to lose her. She's going to fall behind there. But Yolanda goes up, and she starts seeing the line here. So we go, okay. And so Yolanda starts seeing the line here at -5. Yeah? And I'm going to turn -5. Oh, I won't do it like that. I'm going to turn my -5 sideways so we can look at it this way. So -5. And it's included, so we get a bracket here at -5, right? And then Yolanda keeps going, and she goes up. She sees it goes up forever, and forever means infinity. If we're doing it sideways, it looks weird. It makes it look like I'm writing an 8. But if I turn this way, you'll see that I'm saying bracket -5, because that's included, to infinity. And if that helps you, that's awesome. If not, you can just go and say start, stop, whatever one works for you. So that's a curve one. Now we're going to talk about something a little more tricky. And you say, what do you mean, what's tricky about this, Mr. Gray? Well, go ahead and try it and hit pause and do it. And I'm going to assume you did do that, so I'm just going to keep going. So linear, well, definitely yes, that's definitely a straight line. Is it continuous or discrete? Well, it has arrows, so its end behaviors means it goes on forever. So that's definitely continuous. Is it a function? Well, when I do that vertical line test, as I go across, when I get to -2, what happens? If my line was actually straight, you would see that it hits it everywhere. So is this a function? The answer is no, because there are multiple values for x. It's a broken function. I keep on pushing different numbers in the vending machine, the same numbers in the vending machine, and it's giving me different answers. And so the domain on this one is pretty tricky. Kids get confused with it. So if I'm taking Xavier over here, and I say, okay, and I don't see it, and also I see a number. What's my number? -2. But that's it. What's my n? -2. So some people make the mistake of doing like -2 to -2. But does that make sense? No. It just means that you have one value. So you can either put your domain as -2, or if you want to, you can put D is the set containing -2. There is no interval notation when you're going one number, because it's not a start and stop. It's just the number. So next we have the range, and again, range, we're going to ask for Yolanda's help, and she will go up, and she says, okay, it goes on forever here, so that's definitely a -infinity, right? And then she goes up and says, oh, it keeps going forever, so it goes from infinity to infinity. So if I write that out sideways, or the correct way, -infinity to infinity, and remember that infinities are never included. Okay, now we get a nice, interesting one. That is a crazy look at it, Mr. Craig. What do I do? Well, let's talk about the stuff we do know. Hit pause and go ahead and try to solve everything you can. Don't wait for me to give you the answer. See if you can figure it out on your own, and then see if you got it right. This is a way you know you're getting it. All right, so is it linear? Well, that one should be obvious. It is, not linear, because this is definitely not a straight line. Is it continuous or discrete? It is continuous because there's no breaks in the line from here to here. So this is continuous. And then, is it a function? Well, if I do the vertical line test, that arrow means it goes forever that way. But when I get to this point over here, I start seeing two values for x. So it does not pass the vertical line test. So this is not a function. And then finally, we talk about the domain. And this is where people get confused because they think, oh, I need to start here and follow along like I'm going up chutes and ladders. But you're not actually following the line. You're not chasing the line. You're just literally looking at the x-axis. And if we're doing it the way that Mr. Nelson does in the class, we're saying, okay, as I go down the x-axis, the first time that Xavier spots the line is right here. And that is at 1, 2, 3, 4, 5, 6, at -6. So I'm going to put that up here. The problem with this, though, is that because it looks like it hits there, there's not an actual point on the line. It just crosses close to the line. We can't assume that that -6 is included. It just approaches -6 and never crosses -6. So in that case, we do not use included. We use parentheses for not included. And then, as we go on, it does not stop here. That's where this point stops, but we're looking at the x values. There are x values all the way over here, and there are x values going forever here. So we say, okay, it goes forever to infinity, and so that's never included. So my domain ends up being from -6 to infinity. And again, we didn't include the -6 because while this came close to this line, we don't know that it actually touches the line. So it's considered to be not included. Now, again, this is where things get tricky again, and I will use Yolanda, but she keeps on falling behind the board. So if I'm Yolanda and I'm going up, some people say I start here, but the thing is, you're saying that this is where y values start. But again, we're not chasing this around. I see y values lower than that. In fact, there are y values all the way down here. So really, when I'm going up, the first time I see a y value is right there. And that is at -1, 2, 3, 4. So at -4, right? And let's see if I can turn that sideways. At -4, I see that the line approaches. I don't know that it actually sits there. If this had a point on it like this, then I would say, oh, it's definitely included. But it doesn't have a point. So all I can say is it's approaching that -4, which means it's not necessarily included. And then as Yolanda would go up, you say, well, it stops here. No, because this arrow is going out, but it's also going up. So eventually it'll go up, 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 up. It definitely goes to the right faster than it goes up, but it still goes up forever. So it goes to positive infinity. And infinities are never included. So if I was to write that out, range is from -4 to infinity. And again, the biggest part people have a struggle with is they want to start here, but I have to look where my lowest x value is. So there's one. Let's try one last one. Again, go ahead and pause it and see if you can answer it. I'm assuming that you're going to pause it and you're going to be not going to be a passive listener. You're going to be actively trying these on your paper. Okay, so we're assuming you did this. Is this linear? And that's an obvious no. Is it continuous or discrete? Well, there's a point there, but it doesn't break the line. It's not like a break in the line, like an open circle. So this keeps on going and it never stops. So we're going to say that this is continuous from this point on. So yes, this is continuous. Then, is it a function? Well, while it kind of goes up quick and weird, it definitely never has more than one value for x. So this, yes, is a function. And now, let's get that domain and range value again. So domain, we look at domain and we say, okay, where, as we go to the line here, where does it start? And I see that my first point starts there, and that is at -4. So I'm going to go -4. And because that's a filled in point, I'm going to put a bracket. Sorry, I almost put a parenthesis there. And then I keep going, and it goes up there, but we don't care about that. We're looking at the x values as they go across. And that arrow means that the end behaviors tell me that it goes on forever, which means it goes to infinity, which is not included. So from -4 to infinity. The -4 is included because it has a filled in circle, but infinity is never included. Now let's look at the range. And again, some people think, oh, we must start here because that's where the point starts, but this arrow goes down forever. So even though it goes like this and then goes down, all I care about is as Yolanda comes up, this arrow is going to keep going down forever and ever and ever. So this goes and starts at negative infinity. Negative infinity, right? And infinity is never included. But then I go up, and Yolanda says, okay, I got negative infinity, it goes up. I see a point there, that's fine. It doesn't stop there though. Even though the line started from that point, it doesn't stop there. It goes up to here, and that is at 1, 2, 3, 4, positive 4. So we put a 4 here, and we ask the question, is that filled in? It is. That means 4 is included, which means I'm going to put a bracket. And so that's how you do these. Hopefully you can do the ones below and knock this out. All right, we'll see you for the next one.